Guys, what's up? It's week 5, and we're doing midterm review. And I will be doing question 1, error correction. And I'll go over the problem first. So, Sylvia would like to send a secure message to a Moog over a channel size n. This means Sylvia can send the most n packets at a time across the channel. However, the channel is not very reliable. And then assume the channel behaves as follows. You first can send n packets. There's no errors. The second time you send a message with n packets, there's one corruption. The third time, there are two corruptions, and this keeps proceeding all the way till the n plus first time when you send n packets, and now all n of your packets are corrupted. So we're asked to find the maximum size message that we can send. Now, the way we would go about this is first by thinking about, I'm not going to prove this, and this is from the 70 notes, but we're given that if we want to send a message and there are k general errors, we need to send the size of the message that we want to send, which in this case we're going to call x, plus 2 times the number of general errors, and this would be the total number of packets we'd have to send to still be able to decipher a message of size k. What's interesting here is that we're kind of starting out with the maximum number of packets we can send, and that's size n. So what we're going to do here is we kind of know how the total number of packets we can send and like our constraints on the let me this out. Total number of packets that we can send, which is n, and then our constraints. And then we know that the number of the packets of the size message we want to send plus this constraint equals the total number of packets that we can't send, which is kind of n over here. So what we're going to do is rewrite this out, swap out x for max packets plus the total number of general errors times 2 is equal to the total number of packets that we can send with each message. And then we know that the maximum number of packets per message that we can send is n, is the total packets that we're given, channel size n, minus 2 times k, the number of general errors. Now, the next step from here is that as we know that there's an error each time, right? And then also we can see from here, each time we start with one error and keep progressing, keeps getting bigger and bigger, as we see over there. But eventually, once k is equal to half the size of the channel, we won't be able to send any more packets without all of them getting corrupted. And that's the key thing to note here. So once there are n over 2 corruptions, we're kind of done. So to find the total number of packets we can send over the channel with each message send from 1 to all the way to whatever it is, we can write that out as a sum, starting out with this from 0, the 0th error, to all the way up to where we have n over 2 corruptions, and we have a maximum number of packets we can send. So summing the maximum number of packets we can send from 0 to n over 2 times. Now that would be leaving the answer in a summation form. And we're technically done here, but let's simplify this, right? Because we can. This can, with the inequality we have up above, this can be simplified out to n to k. And to simplify it out, this little sum we have here, this little fact, if we're summing from 0 to n of I, that's equal to like the average from 0 to n times. We're going to use that as we're summing the number of errors when we expand that out. But let's first do n. You can factor the n out, and 0 to n over 2, summing 1, 0 n over 2 times is just n over 2 plus 1. Now we gotta simplify this over here. And now we're gonna use that this little summation over here. We get that that summation is equal to this. Simplification, a little bit of expansion. Let's move this over here. This is just reminding you guys kind of unnecessary, as all we had to do was leave our answer as a sum, but just doing this for the sake of completion. Oh, there we go. And then if we simplify this, we get the total number, the maximum number we can of packets we can send as a function of the size of our channel is negative distributes is this. And that completes the problem. But the key idea here is understanding how to manipulate the like the Berklamp-Welch, the error correcting codes thing with general errors, n plus 2k, realizing that you're constrained by your errors, rearranging things to find the maximum number of packets per message send, and then summing that up n over 2 times, because with your max packets equation, you realize that you can only keep sending your packets until you have n over 2 errors. Yeah, n over 2 errors. And that's problem 1 for week 5. See you next week.